So, in this huge race to adopt generative AI, there's a massive challenge staring every single company in the face. How do you unlock the incredible power of your most valuable data without putting it at catastrophic risk? Well, the solution isn't just a single tool. It's actually a brilliant architectural blueprint. Let's dive in. Right at the heart of this is something the source material calls a strategic paradox. You've got your most sensitive data, the very fuel for your AI, and it has to be two things at once: meticulously protected, but also fully accessible. I mean, that sounds completely impossible, right? And getting it wrong can be, well, disastrous. And this is really the billion-dollar question that leaders everywhere are asking themselves. How can you possibly let your teams innovate and move fast while making sure that your most sensitive customer data, your health data, your financial data remains absolutely, perfectly secure? Okay, so the answer isn't in some magic off-the-shelf product. It's in a blueprint. And honestly, the best way to wrap your head around this blueprint is with a really powerful analogy: building a modern skyscraper. Because a truly trustworthy AI system, just like a skyscraper, has to be constructed in layers, right from the ground up. So let's start with the groundwork. Why is this whole AI data dilemma so incredibly urgent right now? The simple answer is that generative AI doesn't just introduce new risks, it actually amplifies the ones you already have to a whole new level. What we're looking at here is what the source calls a cascading failure chain. First, you have new attack surfaces, like prompt injection, creating all these new vulnerabilities. Then, navigating compliance rules like GDPR and HIPAA becomes exponentially harder. And if you react by locking the data down too tightly, well, it becomes useless. You end up being forced into this false choice between security and innovation. So, how do we start building our skyscraper securely? Well, we start with the most fundamental layer of all: the zoning laws. Think about it. In city planning, zoning laws are the rules that protect the community before a single brick is even laid. In the world of AI, these are the data privacy regulations that govern the data itself. And the core technology that makes these zoning laws work is something called data tokenization. Now, instead of just locking data up, tokenization actually replaces sensitive information with a non-sensitive, totally unusable substitute, a token. This neutralizes the risk right at the source. The absolute best way to understand this is the coat check analogy. Imagine you're at a fancy restaurant. You hand over your valuable coat, that's your sensitive data. In return, you get a simple little ticket, that's the token. Now that ticket is completely useless to a thief, right? But for you, it's the key to getting your original coat back safely whenever you need it. It's simple, but it is incredibly powerful. So you might be thinking, wait, isn't this just encryption? And that's a great question, but as you can see here, there's a key difference. Encryption scrambles data that's still there. Tokenization replaces the data entirely, vaulting the original somewhere safe. And that's a crucial distinction, because using tokens is often way more efficient for AI workloads than constantly encrypting and decrypting everything. And here's where it all connects right back to our skyscraper. Tokenization is what allows you to comply with these major global zoning laws almost automatically. For GDPR, it means you're not putting sensitive data, the casino, right next to a public model, the school. For HIPAA, it means you're not displaying private patient records on public billboards. It's all about creating safe, designated zones for your data. All right, our foundation is secure. The zoning laws are in place. Now we need to actually build the structure itself. And that brings us to layer 2, the building codes. These are the official AI governance frameworks that act as the blueprints, making sure the system is built responsibly from the start. This is exactly where governance frameworks come into play. You can think of ISO 42001 as the official architectural plan. It's a global, auditable standard for managing your whole AI system. And the NIST AI RMF, that's like the engineering code that ensures the structure is not only strong, but also fair and responsible. You absolutely need both the plan and the code to build something truly worthy of trust. Okay, our skyscraper is designed and it's constructed according to code. But what about real-time threats? A building isn't really complete without fire alarms, sprinklers, and security guards, right? This brings us to our final layer, the active safety systems that protect the live AI application from moment to moment. And let me tell you, the threats are very real. The source uses some fantastic analogies for this. Prompt injection is like an arsonist trying to trick your AI into burning the place down. Data poisoning is like a saboteur secretly using contaminated concrete in your foundation. Insecure output is like faulty wiring that could spark a fire at any moment. And unauthorized agent actions are like rogue elevators just going completely haywire. Each of these threats needs its own specific defense system. And here's the most crucial point. You can't just pick one layer. A skyscraper with a strong foundation but no fire alarms is just a death trap. An AI system with great governance but untokenized data is a breach waiting to happen. You need all three layers: the zoning laws, the building codes, and the safety systems, all working together in perfect harmony. And this really brings us to the heart of the matter. This isn't just about a technical checklist. As the source material puts it so well, it's about the architectural discipline required to construct something not just powerful, but worthy of human trust. So, as you move forward with your own AI initiatives, ask yourself this one simple question. Take a hard look at your foundations, check your blueprints, and test your safety systems. Is your AI built on rock, or is it built on sand?